Question: why can't my hand pass through a solid wall? Is it because my hand is solid and the wall is solid, and therefore a solid just can't pass through another solid? Now, that's too simple, right? If you ask Google or an AI, they're going to tell you that this is caused by electrostatic forces, the repulsion between two negatively charged electrons. As the electrons in your hand meet with the electrons on the wall, the negative charges repel each other, creating a force between these two objects and preventing your hand from going through the wall. But in fact, this story is not complete. I wouldn't be making this video if I didn't have something new to add. So in fact, you have to look at this question in a deeper way, in a quantum mechanical way. The more you zoom into the problem, the more you notice that things are not what they seem. So today, we're going to talk about quantum mechanics of what happens when an electron meets another electron. First of all, here is one electron. Although it looks like there's so many different electrons here, in fact, they're all the same electron. The electron has a chance of being anywhere within this dense probability cloud. Scientists call this cloud an orbital. It doesn't mean that it's orbiting anything, it's just that it is what it is. They call it an orbital, and the electron has the ability to be anywhere. Only when you look at the electron very closely do you find out where it is, and the electron can be anywhere within this orbital circle. That's what all this question marks about, because you don't know where it is. The electron doesn't know where it is. Electrons don't actually have a fixed position until they are observed. This is one of the strange things with quantum mechanics. And it gets even stranger if you consider what happens when one of these electrons meets another electron. Effectively, you have two different probability clouds clashing together, creating this pattern, which is known as the anti-bonding orbital. In the anti-bonding orbital, there is an area in the center that does not have any electrons, but the electrons can appear in this almost pear-shaped like cloud on either the left side or the right side. That's not all. In fact, there are also circumstances called the bonding orbital, where instead of not meeting, they don't meet this time. And this is what happens in a bonding orbital. The electrons can join together. In fact, they can come to the same space. And you might wonder, I thought that negatively charged electrons should push away other negatively charged electrons. Or actually, you've been lied to. Quantum mechanics tells you a deeper reality. Electrons can in fact bond together. Negative can bond with negative. It's just that the chances, the probability, the chances of this happening are rarer. It is more common to see the anti-bonding orbital, where the electrons don't want to mix together. What causes this difference? What causes electrons to sometimes bond and sometimes refuse to bond? So, the main thing is the spin of the electron. As long as the electron is spinning in different directions, they can bond. But when they spin in the same direction, either, spin up or spin down, then they cannot bond. So I've actually decided, forget all electrons. Let's just look at some bees, okay? So we are representing the electrons as ghost bees, and I'm using ghosts because they can actually pass right through each other. They're not solid. Electrons are not solid. Clouds are just clouds of chance. They're not solid either. So as long as the bees are spinning in a different direction, they are pretty happy to spin. They're pretty happy to overlap in the same space. So in fact, electrons can overlap in the same space, as long as they are spinning in different directions. And because this is quantum mechanics, they say you can only spin up or spin down. There's no spin left, spin right, no 45 degrees. It's just up and down. That's another strange thing about quantum mechanics. But with this thing about B, so sometimes the electrons will combine together to have the exact same location in space. But there is a higher chance that they do not, because it is more likely for the electron to be, in opposite phases, in the same phase than opposite phases. And in this case, they form the anti-bonding pattern where they stay apart from one another. This is because the electrons obey a Pauli exclusion principle, which is more of a social contract than an actual rule of electrons. It is this idea that, the bees just don't like to be close to one another. And electrons don't like to be close to other electrons. They cannot have the same quantum numbers. And by this, what I mean is, the quantum numbers there are 3 quantum numbers that correspond to the location of the bee, of the electron. But there's one last one corresponding to the spin. So in fact, as long as the spins are different, one is spin up, one is spin down, the quantum numbers will not be the same. And since they are not the same, they can happily be in the same position. But if the quantum numbers, the spin is the same, then the quantum numbers would be the same if they had exactly the same position. Quantum mechanics does not allow this. And therefore, when it doesn't allow this, it forms the n-type bonding orbital, where instead of combining together, they separate.